These are the contents of this video session. We will be getting into in depth of about what is sequence diagram, the difference between collaboration and sequence diagram, various notations which is followed in sequence diagram, and how to demonstrate concurrency and object states. So as we have already discussed in the previous video session, interaction diagram is mainly used to demonstrate the list of objects and their interactions for a particular use case. There are two common interaction diagrams. One is called as collaboration diagram, which is used to emphasize the structural relationship, and next is a sequence diagram, which is going to say about the sequence of message in a time ordered fashion. Sequence diagram shows how two objects interact with each other in a timely fashion. So this is very much similar, that is isomorphic with collaboration diagram. It has same elements which is used over here, but apart from that it also has two other parameters. One is called as object lifeline, other one is called as focus of control. So the focus of control is also called as activation. As like in collaboration diagram, sequence diagram can also be represented using descriptor form and also instance form. So to repeat, descriptor form is the class representation, instance form is called as object representation. This slide focuses on the difference between collaboration diagram and sequence diagram. As we have already mentioned, collaboration diagram says the structural organization of object. That is, it is going to say how two objects associates with each other. But sequence diagram is used to say what are all the message that has been passed between two objects in a time-based manner. It is used to capture the order of messages which flows from one object to another object. Next, we can go for the notation of sequence diagram. Remember students, this is the notation which you are in need to use for your 5th lab experiment. Sequence diagram is usually drawn in two different axes. One is called as vertical axis, which is running from top to bottom. Other one is called as horizontal axis, running from left to right. So we can see an example in this slide. In this example, we have three different objects. One is called as register, other one is called as registration manager, third one is called as UML course. So this sequence diagram is drawn in two axes, as I've already mentioned. In the horizontal axis, we used to represent the objects, that is register, registration manager and UML course from left to right panel. Similarly, we have a vertical axis also. So this is going to say the lifeline of the particular object in this diagram. The next parameter is called as object lifeline. This is going to represent the duration of any object over time. So you can see in this diagram, the lifeline is represented as dotted lines. So it starts as soon as the object is created and it flows until the work of every object prolongs, after which the lifeline is destroyed. So remember students, it is denoted as dotted lines in a vertical fashion. The next parameter is called as messages. Messages pass between instances, that is object, and it flow horizontally within the object lifeline. So you can see in this diagram, messages are represented by using single straight line with thick arrow ahead. So arrow is going to represent the direction of message flow. If it is a request message, continuous line is used to demonstrate. But if it is a return message, you can see dotted lines will be there to demonstrate the return message. That is a reply message from one object to another object. So remember students, messages are passed just before the lifeline ends. The last parameter is called as long thin rectangles, which is used to indicate the lifeline or the focus of control of any particular object. So in this diagram you can see there is a focus of control for registration manager which starts as soon as add course message is initiated, and it ends as soon as it initiates a create message, after which its existence, that is its flow of control, goes to some other object. But remember, certain objects can have focus of control throughout the complete diagram. So in this example, register has the flow of control, that is focus of control, throughout the diagram has been ended. Next parameter is called as instance destruction. So this is mainly used to destroy objects which has been created temporarily. For example students, if you wish to destroy the existence of an object after its work is over, you can demonstrate that in sequence diagram as well. So you can see a large cross mark is given over here. So after the cross mark, you cannot see the dotted lines, that is the lifeline of the object prolongs this. So meaning of this is, after destroy message has been passed from registration manager to the particular object, its point of deletion starts. This is called as instance destruction. Next one is called as iteration. So as we all know, iteration means calling the same function or same procedure again and again. So this is done by having a rectangle box above the message for which the particular iteration happens. Below the box, you can see the iteration expression is written over here. So as we have already discussed in collaboration diagram, star is used to represent that the particular function is going to get executed more than once. And within the square bracket, the iteration expression is written over here. Next is called as branching and self-delegation. So first we'll go for what is self-delegation. Self-delegation means calling a function by itself again and again. So you can see here an arrow mark which starts, that is a message, starts from registration manager and again goes to the same registration manager. And also you can see there are two different focus of control. One is called as outer focus of control and the next one is called as inner focus of control. You can see nested focus of control arises after self-delegation messages is called. So this example we have already discussed in the collaboration diagram, which is used to register a student called as Jim to a course called as UML. So for which initially we are in need to find a student and return his particular parameter, details in an object called as yes. Similarly, find a course called as UML and return the particular course details in C. So for which we have self-delegation and the corresponding controls which is present over here. Now you can see what is branching. So based on the values which is present in yes and C, that is, if there is no valid student called as Jim, then S holds null value. Similarly, if there is no valid course called as UML, imagine UML course has been deleted. In such a case, C holds a value called as null. So in such a case, we are in need to go for branching based message transfer from registration manager to the registrar. So you can see here, a branch of control arises. So based on the value which is present in SNC. So if SNC holds meaningful value, then OK message is transmitted. Else you can see a branch of control arises over here. So this has a separate flow of focus of control. So this takes messages such as there is nothing in C and S, we can reply as nothing found. But if there is any valid course but there is no valid student called as Jim, then student not found reply messages transmitted. And if there is no valid course called as UML but there is a valid student details, then course not found details has been, error messages returned back. Remember students, for every message we used to represent by using continuous thick line, but for reply message we used to have dotted line representation. So such particular thing is called as branching and self-delegation. Next one is called as concurrency and active object. So concurrency, as we have already discussed in collaboration diagram, is used to demonstrate the list of active objects which are all active at the same time. So we cannot say always one object is active at a time. We can have multiple objects active at the same time. So this we have already discussed, this example we have already discussed in the collaboration diagram video itself. So you can see as soon as activate message passed from the security guard, immediately you can see monitor messages transmitted at the same time. So here as two messages are arised at the same time, you can see a fork-like icon is used to demonstrate this concurrent object execution. So fork means from one point, multiple messages are starting and multiple triggers are being executed. Similarly, the list of objects who are all active at the same time is demonstrated by using thick border. So this representation is called as concurrency and active objects. The next notation is called as object state and constraints. So you can also have object state representation in sequence diagram as well. In this example, the customer will be raising an order and the order manager will trigger the message to create a special instance which is called as order. So initially the order is said to be unpaid. As soon as accept payment is triggered, then the state goes for the paid state. Next is called as constraints. You can also give constraints within sequence diagram. So this is done by something called as flower brackets. So here the idea is that two different labels are created like A and B, which is going to say the deadline for the amount payment. So here the constraint is if B minus A, that is if the B is the final date of payment and A is the current date. So if B minus A, if the duration is only 28 days or below, I can accept the payment. Idea here is that I cannot accept any payment beyond this label called as B. So such constraints can also be created or demonstrated in sequence diagram. The diagrams and the contents are referred from the book cited here. Thank you for your patient listening.